We decided to build this project from the ground up using only NOT and AND gates. Connecting a NOT gate to an AND gate negates the outputs of the AND gate and forms a new gate called a NAND gate. Inverting both inputs to the NAND gate creates an OR gate.
Looking at the image shown, we see that for binary addition, when both inputs A and B are 0, the sum will be 0 and the carry is also 0. When either of the inputs is 1, the sum will be 1 and the carry will be 0. And lastly, when both inputs are 1, the sum will be 0 and the carry will be 1. When we inspect the truth table of all the gates we have created so far, we see that the carry and the AND gates are identical, and thus we can represent the carry with the AND. Upon further inspection, we see that the sum is similar to the OR except when both inputs are 1.
To create this, we connect both inputs to a NAND, which will only be 0 when both inputs are 1, and connect both inputs to an OR, and then connect the outputs of the NAND and OR to an AND gate. The resulting circuit perfectly represents the sum and is usually called an exclusive OR gate. We usually end up adding 3 bits when there is a carry from the previous digits. So we add the sum of the first 2 inputs to the carry from the previous step. We add an AND gate to check if the sum of our first 2 inputs is 1 and there is a carry in bit, in which case the carry out bit will be 1. And the carry in bits with the sum of the inputs, that will be the total sum. If the 2 inputs are 1, or the sum of the 2 inputs is 1, and the carry in bit is 1, then the carry out bit will be 1. The resulting connection is an adder, a 1-bit adder.
We then cascade the 1-bit adder to form an 8-bit adder, that's in 8 places. We display the sum and connect the carry out bits to the carry in of the next adder. If there is a carry out after in the last adder, it implies that the output is greater than 255, which is the greatest decimal number that can be represented with 8 bits.
This scope shows a 1 or 0 depending on the size of the output sum. If it is greater than 255 and 0, this function breaks the list into 8 individual Boolean values and is a copy of this one. The convert to list function concatenates the input and turns it into a string to be displayed on the scope. The 2 inputs are 1 and 3 in binary, and the output is 4 in binary. You could also try different numbers, say 17 and 14. The output is 57 in binary. Thanks for watching.